All right, folks, we are going to get into 3.6 today, which is critical points and extrema. And I'm going to bring you right over to the notebook right away to get started. And, well, that's not the one I wanted to go to. Let's see. Sorry about that. I want to go to that one. All right, so still want to get rid of that for the moment. Now, critical points and extrema. What we're talking about with this is being able to, it's kind of adding to our knowledge of functions. All right, what we're going to be doing is looking at, like we previously did in earlier sections, we looked at where is a function increasing or decreasing. Well, if you think about the natural consequences of that, if I talk about a function that is increasing and then decreasing, what happens? If it goes from increasing to decreasing, it naturally has, at some point up here, a maximum value, right? It's along this curve, it would have a maximum value. So we're going to talk about what kind of maximum. We're going to look at how do we find maximums, things of that sort. And on the other end, if I have something that's now decreasing and then begins to increase, somewhere along here, there's going to be a minimum. So what do we call these things, these maximum minimums? These are what we call our extrema. All right, these are from a bigger set that we call critical points. All right, there are certain points along a graph that we consider to be critical. They are points that we investigate, and you're going to see this expanded in a great deal in calculus. But the basics of critical points are we have maximums. All right, that's one type of critical point, is a maximum. There's also minimums, of course. We just mentioned that. So you have maximum, minimum, and there's a third one in terms of a critical point that we call a point of inflection. Now, I didn't mention this one yet, and it's not one that we're going to be able to precisely identify where it's at, but we're going to be able to understand what it is. And the idea of it is this: as we go from increasing to decreasing in this graph that I just drew, we have this shape that's kind of like a bowl facing down. This is what we call concave down. It's got concavity. That's what that bowl shape is a concave shape, and it's facing downward. Well, but then we look over here and we have a bowl shape facing upward. This is concave up. When you have a graph that changes from concave down to concave up, somewhere in this middle ground in here is a point where it changes, where the curve is concave down and becomes then neutral and then concave up. That neutral point is what we call our point of inflection. All right. It's that point where we see something changing concavity. We see that. Now, you're not going to be asked to find points of inflection. You're only going to be asked to identify if they give you a point on a graph and say, is this a max, min, or a point of inflection? You have to recognize that it is a point of inflection because it's a change in concavity. So that's all we're going to talk about with point of inflection is, do you recognize that that is a point of inflection because it's a change from concave down to concave up, or vice versa? It could be from concave up to concave down. That, again, could be a point of inflection, say over here somewhere. All right. Our biggest goal in this section is to talk about our maximum minimums. When we talk about a maximum or a minimum, there are two types of these. And your book will refer to them as a relative max and min, or an absolute max or min. Now, I want you to also understand that relative is also in other books called a local maximum or minimum. An absolute can be called global, just in case you hear those words used, maybe by your teacher. Some of us learned it differently, and they may talk about a local or global extreme rather than relative or absolute. Your book uses the relative and absolute idea. So what does this mean? All right, I'm going to look at a graph. We're going to look at a few graphs, and with those graphs, we're going to talk about what would be a relative versus an absolute maximum. I just wanted to get those words out there and get you familiar with the idea of them, and then we're going to look at some graphs, all right? So let's take a look at a graph. And they may ask us, as it says up here, to locate and classify any extrema for this graph. So what you do when you're looking for extrema as we did with any kind of graph that we talked about in the idea of intervals, when we were finding intervals that were increasing or decreasing, I'm going to start at the left end of this graph and I'm going to trace. And right now we've got decreasing, right? The graph values are decreasing. The Y values are decreasing as I go down this. And then at this point, they become increasing. When you get decreasing going to increasing on the graph, as you go left to right, if it's decreasing and then becomes increasing, you have a minimum. All right. If that in the graph is the lowest point anywhere on the graph, then we call that an absolute minimum, meaning it is absolutely the lowest point on this graph. There's no other point that is below here, no other Y value for this graph. So this is an absolute minimum. Went from decreasing to increasing, so it's an absolute minimum. Now, if we continue to trace, we now have this increasing graph coming up to here, and it changes to decreasing. All right, so it went from increasing to now decreasing. Increasing to decreasing as we go left to right is going to be a maximum. And again, we look to each side and we see that the values are lower. But there are values up here. This goes on forever, right? And so does this. So there are other values on this graph that are greater than this maximum. So this is not an absolute maximum. This is what we call a relative maximum. Why do we call it a relative maximum? Because relative to the points to each side, it is larger. It's larger than any point to the left and any point to the right. So it is a relative max. All right. And we continue to trace on here. We have decreasing and we go to increasing again. So we have increasing here. So going decreasing to increasing left to right, what did we say? We have a minimum. Now, what kind of minimum? Well, again, looking at this graph, there are points that are lower than this on this graph all over here. So this is a relative minimum. Should have left room to write it above. This is a relative minimum. Okay. And if we needed to identify them, we can see what points these are. This is the point 1, -2. Whoops, -2. And it says locate, that's locating them, 1, -2. Classifying them, that's this part. All right, this is the locate. This is the classify. Classifying means two things, relative or absolute, max or min. So if we go back and do these others, this one located is -2, 1. So -2, 1, it's a relative max. So we've located, classified. Going back to this one, we're back 1, 2, 3, 4, 5, 6. So -6, 1, 2, 3, 4, 5, 6. -6, -6. Whoops, I didn't change colors. I thought I did. -6, -6. So all of these are located and classified. Now, I wouldn't normally do this on the graph. If they asked me to do this, I'd probably list them to the side. And I would just write, say, -6, -6, and say that is an absolute min. And then I would say that we've got -2, 1, and that is a relative max. And then we've got 1, -2, and that is a relative minimum. And we have on this graph, there is no absolute max, right? It goes on forever, so there is no absolute max. And that's all you have to do, all right? This is the answer. This would be my answer blank answer for locate and classify the extrema. Now, just to revisit one idea I talked about in the previous one, where would I guess, if I were to guess where a point of inflection is, I'm thinking a point of inflection would be somewhere around here, somewhere in this portion. There would also be another one somewhere around here. Again, we're not going to have to locate or classify, though. Those are not extrema. They are just points of inflection. But I'm just bringing that topic up so we can kind of look at this and say, oh, it looks like this would probably be a point of inflection, right? And this too. The way this kind of bends that way, there might be one in here too, but I don't see enough in the graph to say that for sure. But definitely a point of inflection somewhere in these two, right? Somewhere in those areas. So if they had asked me, say, -4, -2, what is that point on the graph? I'd say that's a point of inflection if I had to choose. All right. So again, just something to connect it to what we did. So let's do this one. Again, I look at this. As I go from left to right, I'm increasing, then decreasing. So I see right here, there is a point of inflection. What is that point? That's 0, 2. What kind of point is that? That is a maximum. Is it an absolute or relative? It is a relative maximum. All right. Then I continue on. Going down here, I go down to the bottom, and we get 2, negative 2. So 2, negative 2 is my next point. 2, negative 2. And that is a minimum. Decreasing, increasing. That is a minimum, and it is what kind? It is a relative minimum because there's points lower than it. Right? So relative minimum. Those are the only extrema. Now, you can use a graph like this too. If they ask you to locate and classify an extrema, and then they ask you identify increasing and decreasing intervals. They're not going to do this on here, but we probably will have them combined on a quiz where you just do everything. Identify increasing and decreasing intervals. So with something like that, you could then say, now that I know where the maximum minimums are, right? I know it's maximum there, minimum there. It's increasing. Remember I said when we do increasing, decreasing, we do this. Make 2 headings. Increasing, it looks like from negative infinity, using our interval notation, negative infinity to 0. We use the x's from negative infinity to 0 on the x-axis. It is increasing. Then it's decreasing from 0 to 2, right? 2 on the x-axis. And then it's increasing from that point on, from 2 to positive infinity. And we would have identified increasing, decreasing intervals and relative and any extrema, right? Let's keep going. Another example. Gotta wait for this one to load for a second here. All right, locate and classify extrema for this graph. Well, I'm increasing. Now I don't have curves here. This is just strictly increasing until this point. Problem here. Can I say at negative 1, 3 that there is a maximum? I can't because negative 1, 3 does not exist for this graph. So this technically, it goes infinitely close to this. So it continues to move, so to speak. It continues to grow towards that point, but it doesn't hit that point. So I can't classify that as any kind of maximum. But on the other hand, this one has nothing. It's kind of what we call a one-sided max or min because it doesn't have anything on this side because we can't include this. It wasn't leading to it. It wasn't connected. So I look at this and I say from here, it's increasing. So this is a minimum at negative 1, 1. So there at negative 1, 1, there is a minimum. We have to decide what kind of minimum. Well, there are other, this is all one function and there are values less than this. So this would be a relative minimum for this graph because relative to the points that connect to it on this side, it is lower. So it's a relative minimum. So then we increase and we go to this point. This point sharply turns and goes down. That is at 5, 5. That is a maximum. What kind of maximum is it? Well, nothing goes above it, right? This goes down forever. This goes down forever. So that is an absolute max. All right. So again, we have this idea. Now, were there any points of inflection on this graph? No, there's no curves. So there's no point of inflection. These are all straight lines. These are segments. So there's no way to do anything other than find extrema. All right. So we located and classified extrema for that. The last type of problem could be something like this. And what do we do for this? Well, what we have to do for this is pull up our graphing calculator. All right. And what we're going to do is go to y equals, and we're going to put in our function. Well, let's get y equals. And our function is x raised to the 4th minus 3x squared minus 5. And I'm going to do a zoom 6, just a standard zoom, and see if I see everything I need to. I think I see it all. If you want to, you could zoom in a little bit more. If you wanted to say close this in this way and maybe do a window instead of negative 10 to 10, maybe do negative 5 to 5. Whoops, I got to go back. I did something wrong. All right, that was supposed to be a negative 5. to 5. Sorry. And I'll do the same here, -5 to 5, and see if I can still see the whole graph. I like to zoom in a little bit just to see it. Whoa, I went too far. Got to go down a little bit. So my Y minimum, say, going down to here, I'll make it -8 in graph. Now I can see it all, and I can see clearly. So what's going on? First, it's decreasing until it hits this point, then increasing. So we've got to find that minimum. All right, now you have to pay attention to what's going on. We're going to find that minimum, but our calculator will do this for us. It's awesome. You go second, calc, and you see right in here, minimum. So hit 3, and it's asking us. Now, all we got to do is tell the calculator where to look. See how there's a cursor here, and it says left boundary. It's saying, where do I look? Go to the left of that minimum. So I'm just going to use my left key, and I'm going to move this thing left of that minimum. So anywhere over here. All right, that's obviously left of where it was going down, right? So I'm going to hit enter when I'm left of that boundary. And see how this little arrow popped up and saying I'm going to start looking here. Now it's asking me for a right boundary, and it has that cursor still where it was. So now I go to the right of this. And now to the right of it, I'm going to hit enter again. And you see these two arrows. It's going to look between here. It says guess. We don't need to guess. Calculator will do the work for us. If you want, you can go down there and kind of guess. All right, I think it's somewhere around here. But important is just hit enter again. And it tells me my minimum is at -1.22, -7.25. So I know right now I have a minimum at -1.22, and I forgot what it said. -7.25. -7.25. So what kind of minimum was that? Well, again, looking at this, that hits there, goes up, goes down, and up. I should probably check the other minimum first just to make sure this minimum isn't lower than that minimum. If it isn't, then I've got two absolute minimums on this graph, right? Because those would be the lowest points. But let's keep going and see what we get. I'm going to change my window real quick here. I'm going to go back to -10 down here just so I have room so we can see it a little bit better. In fact, I'm even going to go further and graph this again. All right, so now we found this one. Now it's increasing again, and it comes to here. So let's find that maximum. I'm going to go second, calc. I go to maximum, which is 4. And it's asking me again, left boundary. It already tried to kind of go there. I'm going to go a little bit left of that and tell it to start looking. It asks for right boundary. It tells you all the directions right here. I got to go to the right of that maximum. And I hit enter. And then guess, well, you can put it somewhere near it. And I'm going to hit enter. 0, -5. So I got a max at 0, -5. And let's look at that graph again. Is that an absolute max? Well, no, these go on forever up here, right? Even if they don't go on forever, they go above this. So that would be a relative max. All right, let's find that next one. We go in here again, and I'm going to try to find this minimum next. Second, calc, I'm going to find a minimum, so I go to 3, and I'm going to go over here. I'm left of it right now. Left of it right. That didn't make sense, but okay. I'm left of this, what I think is a minimum there, right? So I'm going to hit enter. It asks me for the right boundary. Go look over here, go past it, hit enter. And if you want to, you can guess by going close to it and hit enter. And it tells me, look at that. That's the same as this, isn't it? But now it's positive 1.22, negative 7.25. So the minimum value, that 7.25, negative 7.25, is the same minimum value. So we can say this is a minimum. And it's at 1 point, whoops, 1 point. Leave that. 1.22, negative 7.25. And now we know that these are both absolute minimums. Since they're the same and they are the lowest point, you can have more than one absolute minimum. And obviously more than one relative. But absolutes, you can have more of them if they're the same. They have the same, this has the same depth to that graph. It went down that far. All right, so we've got everything we need in terms of locate and classify all the extrema. This graph goes on forever, and you could check, but this graph will just keep growing from this point on each direction, right? So we've done it using our calculator. Let's do another one. Let's go to this one, and let's put this in our calculator. Y equals, and let's see, let's clear this out, and let's do x raised to the 5th minus 2x raised to the 3rd minus 2x squared. There's my squared key. All right, so let's graph this. I'm going to do zoom 6 to start again. See what happens. All right, looks like we've got it increasing, decreasing, then increasing, right? Again, if you want, you could zoom in a little bit. I might take at least the top end off and the X's a little bit. I always start with a bigger graph, and then I try to zoom in a little bit just to make sure I'm not missing anything on this graph. But I don't want to go too far because it did go low. I'll probably do a little bit cut off on there. And let's graph it here and see if I got everything. Looks like I did, right? Looks like we have up, down, right? And so we have this graph increasing, then decreasing, increasing. From just looking at this, what does it look like we have? What would you say? Do we have any minimums or maximums? All right. I see a maximum here that I would think is a relative max. And I see what I think is a relative min here. And then it just grows and decreases. So I need to find those. So second calc, first thing I'm going to find is that maximum. So I'm going to go to 4. And it's asking me for the left boundary. So I'm going to go left of that, what I think is the max, hit enter. And you can watch these values, the Y values, and make sure that it went up and then it's starting to come down again. Right? All right, so it looks like we're there. And I might go back this way a little bit and say enter. 0, 0. All right, so what do we have? We have a maximum at 0, 0, and that's a relative max. So relative max at 0, 0. We located and classified it. Well, we classified and then located it. Same idea. All right, so now let's find that minimum. That minimum is going to be, again, something we can find with our calculator. I want a minimum, so I'm going to go 3. I'm going to go and look for it. Hit enter. Go left of it, go right of it. Hit enter. And we're just going to hit enter again. And it tells me there is a minimum at 1.34, negative 4.08. If we go to tenths, that would be 1.3, negative 4.1. So 1.3, negative 4.1. And that is a relative minimum we set. And that's what we're going to be doing, guys. Again, we may combine this in later stuff in our quizzes with finding increasing or decreasing, but look how that helps you. Knowing you can do this on your calculator, you can find the increasing interval for this is from here to that maximum. So to the X value of the max. So it'd be from negative infinity to 0, right? Because that was our X value. Then it's decreasing from 0 to 1.3. And then from 1.3 to positive infinity, it's increasing again. So you see how finding these max or mins can help you. Are there points of inflection in here? Yes, there are. Can we find them? No. They're usually somewhere halfway between these max and mins, but they're just somewhere in here. There would be a point of inflection probably right here. But again, we're not going to ask you to find those. It's just if I said at x equals -1, what does it look like the graph would have as a, is it a max, min, or point of inflection? Well, at -1, this graph would have a point of inflection, if anything, right? If any of those three. And that's all we're going to be doing. So you've got some homework to practice this on. Make sure you do this practice. This is not stuff, it may look like it's easy doing it. Make sure you go through and actually do it. There's so many different situations you need to encounter and kind of think through. And then if you get confused, be able to ask questions about tomorrow. Remember, there's no skipping the practice, guys. It's the only way you learn this stuff. So get at it, and we will see you tomorrow.